Today we're looking at lesson 7.5, factoring x squared plus bx plus c. Now in our essential question, we are going to break down and review some important pieces of information. All right, if you look at the essential question, it says, how can you factor the trinomial? Now let's stop right there. We have drilled into our heads for the last week and a half what a trinomial is. How many terms does a trinomial have? 3. The trinomials that we're going to factor today are going to be in the form x squared plus bx plus c. Now let's look at that. If there is no letter or nothing in front of x squared, that means there is an understood what in front of it? 1. So the things that we're going to factor today, the trinomials that we're going to factor, are going to have a leading coefficient of 1. And you're going to hear me ask you on every problem, is this a trinomial? What's the leading coefficient? Because I need you to understand by the time we get to a quiz and a test, all sorts of factoring problems are going to be mixed together, and there's different methods for different types of polynomials. So you've got to be able to recognize this is a trinomial, the leading coefficient is 1, this is the method that's going to work. All right? So that's important. Now, we're going to factor it into the product. So let's stop and talk about the word product. The product is the answer to what kind of a question? Or what kind of a problem? Multiplication. So we are going to create a multiplication problem of 2 binomials. Now, how many terms does a binomial have in it? 2. Okay? So we're going to take a trinomial and we're going to break it down into 2 binomials that we're going to multiply together. Now, look at the question on the board. Do you remember FOIL? I hope so because you just had a test on it yesterday. But let's review it, all right? And we FOILed x plus 2 times x plus 3. Questions like this. So what does the F stand for? First terms. We're going to multiply the first terms. What's the O stand for? Outside. We're going to multiply the outside terms. What's the I stand for? Inside terms. And what does the L stand for? We're going to multiply the last terms. Now, if you look at my fingers right now, when we multiply using FOIL, how many terms do we have? However, the middle 2 terms usually did what? Combined. All right? They were like terms, so we combined them. So our answers ended up being what? Trinomials. Okay? So that's what we answer when it says what did our final answer look like? We would say a trinomial. So look at what factoring is. Factoring is the opposite of FOIL. We take a problem that looks like x squared plus 9x plus 20. We take a trinomial and we make it look like x plus 5 times x plus 4. So on the test yesterday, we multiplied 2 binomials and got a trinomial. Today we're going to go backwards. We're going to take that trinomial and we're going to turn it into 2 binomials that we multiply. All right, now here's how we're going to do that. The first thing you have to understand is choosing the right signs. We have to choose the right signs for these binomials or everything's going to be off. The numbers are going to be off and obviously the answer is going to be wrong. So it's imperative that you understand how to find the signs. So look at these examples. Ax squared plus bx plus c. When the second sign is, now go to the next example. Ax squared minus bx plus c. Look at the first thing in blue. When the second sign is. Go to the third example. Ax squared minus bx minus c. Look at the blue. When the second sign is. So where do our eyes need to go first when we're looking at our trinomial? The second sign. The second sign is going to tell us what we need to know. So let's look at this. Go back to the first example. When the second sign is positive, and if you look at your trinomial, the second sign is positive, the signs will be the same. Awesome. But are they both going to be positive or are they both going to be negative? Well, that's where the arrow comes in. Once I realize my signs are going to be the same, I look back at the first sign, and that is the sign I'm going to use. So you can see at the end of this, I put 2 sets of parentheses, and right smack in the middle of them, I put the plus signs. So your binomials are both going to have plus signs in them. Now, pick up your highlighter. I would also circle that second plus sign. But I want you to highlight when the second sign is positive, and then I want you to highlight the same. Because those are the key words. When the second sign is positive, my signs are going to be the same. Now look at the second example. It says the same thing pretty much. When the second sign is positive, so again, we circle that second sign as positive, the signs will be the same. But what happens when we look back in the second example? When we look back, what's the first sign? So both of our signs are going to be what? Negative. So the signs are going to be the same, but the question is, are they both going to be pluses or are they both going to be minuses? So highlight when the second sign is positive, highlight the same, and then if you want to underline, again, the example, both binomials have a negative sign. Now last, we have ax squared minus bx minus c. When the second sign is negative. So we've got something new to highlight. When the second sign is negative. And if we look at this example, clearly the second sign is negative. If the second sign is negative, the signs will be different. So highlight different and then look at the example I gave you. One binomial has a plus sign and one binomial has a minus sign. Are there any questions so far? Awesome. Now, let's look at how to find the numbers that are going to go into this binomial. Notice the x's, okay, at the very top of our x, okay, and again, we're not going to be drawing these thick x's. These are just going to be normal x's, so you're going to draw them as large or as small as you need, but we want to make sure we can write numbers and we can read them. So at the top of our x, we are going to plug in the coefficient of x. Now, I spent a week and a half also drilling into you what a coefficient was. So somebody tell me, a coefficient is always going to be a what? A number. All right, very good. It's the number in front of x. And understand, some of our problems are going to have a variable other than x, but the idea is the coefficient of x is going to go in that spot. Not x, not a variable, the coefficient of x. Now, at the bottom of the x, we're going to put our constant. Well, you have to know what a constant is. Does anybody remember what a constant is? Because we talked about it, but it's been a little while. Let's think about a trinomial. If I give you x squared plus 2x plus 5, what's the constant in that trinomial? Why? What makes 5 the constant? What's special about 5? It has no variable. It always stays the same. Okay, you're both right. A constant never changes. Well, it never changes because it's not sitting next to a variable and it's never going to be multiplied and change. Okay, so here's the definition. I would add this to your notes if you're still not sure what a constant is. Put this in your notes. A number without a variable. So when I'm looking at these trinomials and I'm trying to factor them, the constant is the number without a variable. And that's going to go at the bottom of my x. Now look at either side of the x. It says factor of constant, and in parentheses it says plus or minus question mark. This is where, once we figure out our signs, we're going to plug the signs onto either side of the x. So we've got to be able to tell, are both of my signs negatives, are both of them positives, or are they different? Is one positive and one negative? Now let's talk about the factor of the constant. What does that mean? Well, if you look at blue, it says factors of the constant must add up to give you the coefficient of x. So factors. Factors are the numbers in what kind of a problem? Factors are the numbers in a multiplication problem. So we have to find two numbers that when we multiply them, we get the constant, but when we add them, we get the coefficient. So I want you to highlight factors of constant, add up, and coefficient of x. Those are the key words. The factors of the constant must add up to give me the coefficient of x. Now, the factors of the constant, those two numbers that we find, that we multiply together and get the constant, we add and get the coefficient, they're going to become the numbers in my parentheses, the numbers in my binomial. Now, let's put it into practice, because I promise you when you see this, you're going to be like, this is amazing. This is so easy. Okay, first question. Is letter A a trinomial? Yes. What is the leading coefficient? 1. So, our x method will work. So, we're going to draw our x. Again, don't draw it so huge it takes up half the paper, but don't do it so tiny you can't read the numbers you plug in. All right, at the top of our x, we are supposed to put the coefficient of x. So what is, in our problem, what is the coefficient of x? Nah, that's the coefficient of x squared. I need the coefficient of x. Big difference. What's the coefficient of x? 7. So 7 goes at the top of my x. Now, my constant goes at the bottom. What's the constant of this problem? 6. So 6 is going to go at the bottom. The next thing I need to find are the signs, because I can't find the right numbers until I have the right signs. So by looking at the original problem, my eyes should go to which sign? The second sign, and I see that it is positive. So my signs are going to be the same, and they are both going to be what? Good. Because they're the same, I look back at the first sign, I see that that's a positive, so I know both of my signs are going to be positive. So I'm putting those into the x. Now, I need factors of which number? 6, the constant, right? I need factors of the constant. The constant is 6. So over here to the side, I'm going to start with 1, and I'm going to work through the constants, the factors of 6. So 1 times what is 6? 6. 2 times 3. 3 times, but that's already up there, right? As soon as my factors start to repeat, I'm done. I have them all. Now the next question is, which set of factors can I add to get 7? But you've got to look at the signs. If my signs are the same, am I going to be adding the two numbers together or subtracting them to get 7? Adding them. Anytime my signs are the same, I add and keep. So, which set of factors can I add and get 7? Then 1 and 6, I'm going to circle them. And then 1 and 6 are the numbers I'm going to plug into my x. Does it matter which order? Nope, because they're both positive. So I can put 1 on the left, 6 on the right, or vice versa. Doesn't matter. Now, the only thing left for me to do is write my binomials, write my final answer. So right underneath, I'm going to put 2 sets of parentheses. What is the only part of the trinomial that we have not really done anything with yet? The x squared. So if I have x squared, how many x's do I have? 2. And I have 2 sets of parentheses in my answer. So what do you think I'm going to do with that x squared? I'm going to split them up and put 1 in each set of parentheses. So that's 2 x's. So one of them is going in the first set, and one of them is going in the second set. Awesome. Now, the only thing left for me to do is drop down those factors that I found. So plus 1, plus 6, and I am finished. I have just factored that trinomial. Now, what do you think would be a good way for me to check my answer? If I wanted to make sure I had the right binomials, what could I do to check that? FOIL. Very good. If foiling and factoring are the opposites of each other, then once I've factored, I can FOIL that. If I come up with anything other than the original trinomial, I know I've done something wrong. All right, now let's look at letter B. First question, is it a trinomial? Class, is it a trinomial?
Yes.
Yes. What is the leading coefficient? 1. So will my x method work? Absolutely. So let's go ahead. Let's draw our x, and let's start putting in our numbers. What's supposed to go at the top of this?
-4.
All right. The coefficient of, in this case, w, is -4. And what's going to go at the bottom? 3. All right, good. Now, my signs. I go back to that original problem. I look at which sign? The second sign, and it's positive. So my signs are going to be the same. But they're both going to be what this time? Okay, they're the same, but when I go back to the first sign, I see a negative sign, so I know both of my signs are going to be negative. Now, I need factors of which number? 3, the constant. So 1 times 3 is 3. Are there any other factors of 3? Okay, but before I plug these in, because it is possible for us to say can't be factored. So just because there's only one set of factors doesn't mean automatically this works. Let's test it. Okay? My signs are the same. So am I going to add 1 and 3 or am I going to subtract 1 and 3 to get that -4? But why? My signs are the same. Who cares if they're negative, right? what is the rule? If your signs are the same, you are supposed to add and keep. So let me ask again. Am I going to add 1 and 3 to get that 4? Or am I going to subtract 1 and 3? I'm going to add them. And when I add 1 and 3, do I get 4? Yes. Okay. So let's plug it in. Does it matter which one goes where? Absolutely not. Now, once they're both there, check your work. What is negative 1 minus 3? Is negative 4 what you were trying to get? Then we're good. Okay. So you see, I don't care if your signs are both positive or if they're both negative. If the signs are the same, we're adding the factors to get the coefficient. Now, what is my final answer, Luca, going to be on this one? W minus 1 times W minus 3. Very good. And I know your natural instinct is to just say X, but you got to pay attention to the variable that's in the original problem. But W minus 1 times W minus 3. And I want you to go to letter C, and I want you to work with the people at your table. All right, is letter C a trinomial? Yes. The leading coefficient is what? 1. So will my X method work? Yes. Okay, awesome. So we draw our X. What is going at the top of my X? The coefficient of Y is 13. And what's going at the bottom of my X? The constant, which is negative 30. All right, Claire, will my signs be the same or will they be different this time? All right, we look at which sign in our original problem. The first sign or the second sign? Good. The second sign is negative, which tells me that my signs in my binomials are going to be what? Look back at your notes. When the second sign is negative, my signs are what? So one will be plus and one will be minus. My signs are different. Now, I need factors of what? 30. So 1. Now, I did hear negative 30, all right? But let's talk about this for a second. Don't worry about the signs right now. The signs will come back into play when we're picking the right factors to go with the right sign. Right now, we're just looking at, we want factors of 30. Don't worry about the fact that's a negative right now. Just find factors of 30. So 1 times 30. 2 times 15. 3 times 10. 4? 5? 5 times 6. And of course, right there, 6 is going to repeat, so we know that we're done. Now, our signs are different. So as we're picking factors this time, are we going to be adding them to get 13 or will we be subtracting them to get 13? Subtracting, because our signs are different. So which set of factors can we subtract and get 13? 2 and 15. Now again, we don't care about the signs right now. When we're picking the factors, so I don't care right now if my coefficient is positive or negative. I'm just trying to do some elementary math. When I subtract what 2 factors, do I get 13? And that's absolutely 15 and 2. Now the signs matter because I need what kind of a 13? Positive. So is the 2 going to be positive or is the 15 going to be positive? 15. All right, let's try it. There's 2 ways to do this. We can either just do trial and error. So we plug in positive 15 and a negative 2 and we try it out. Okay. And what does that give us? What's 15 minus 2? Perfect. We did the right thing. But if we had switched that and done a positive 2 and a negative 15, we would have quickly figured out, wait, that's negative 13, so that's wrong. Okay? The quicker way is this. The sign of the coefficient. Find the sign of your coefficient, and the larger factor needs to go with that sign. So let me go through that slowly. 13 is what kind of a number? Positive. So my larger factor needs to go with my positive sign. All right? So we've got positive 15, negative 2. So my final answer is y plus 15 times y minus 2. Awesome. Now, let's try it again on letter D, and then I'll let you ask questions. Is this a trinomial? The leading coefficient is a 1. So will my X method work? Yes. All right. So let's go ahead and do this. What's going at the top of my X this time? Good. I haven't had anyone miss that all day. There is an understood 1 right there. So the coefficient is -1. What is the bottom of my x going to be?
-42.
The constant, which is -42. Now, will my signs, Noah, be the same or will they be different?
Different.
Good. The second sign in the original problem is negative, so the signs are different. Now, I need factors of what? 42. Okay, just 42. So 1 times 42, 2 times 21, 3
14.
times 14, 4,
No.
5,
No.
6
Times 7.
times 7. Now, we know they'll start repeating, so we have all of our factors. Now, we're picking factors. Are we going to be adding them to get 1, or are we going to be subtracting them to get 1? Subtracting. Does everybody agree with that? So, which set of factors can we subtract and get 1? 6 and 7. They're the only ones. We subtract 6 and 7 like we would in elementary school, and we get 1. Now we got to decide about the signs. So, Abby, which one's going to be positive and which one's going to be negative? All right, she says 6 is positive and 7 is negative. Let's check it. What is 6 minus 7? Is that what I needed? Absolutely. All right. So trial and error, or she knew the coefficient was negative, so the larger factor needed to be negative. Now, the only thing left is our final answer. Abby, what's our final answer on letter D? Very good. Now, what if I had put v minus 7 times v plus 6? Is that the same thing? Absolutely. Does not matter. As long as the right number and the right sign are together, it doesn't matter which order the parentheses are in. All right, any questions? Awesome. Let's move on to example number 2. It says solve the equation by factoring. Now, you guys did that on your test yesterday. However, either the problem was already factored for you, or to factor it, all you had to do was pull out a GCF. Now, that's good because in a few days, we are going to have a whole bunch of different types of polynomials that we're factoring, and sometimes we are going to pull out a GCF before we do this X method. Okay, so that is something you need to know. But for today, we're just focused on the X method. So look at letter A. Remember, just like last time, everything has to be on one side and it has to be set equal to 0. So is that the case in letter A? Yes. So we can go straight into factoring this. All right. Is it a trinomial? What's the leading coefficient? The leading coefficient? 1. So will the X method work?
Yes.
Absolutely. All right. So here we go. What's going at the top?
3.
What's going at the bottom?
2.
Our signs will be,
Same.
and they will both be very good. I need factors of 2. So 1 times 2. Am I going to be adding these or subtracting these? My signs are the same. I'm going to be adding. Does 1 plus 2 give me 3?
Yes.
Good. So I plug them in. And what is my binomials? What are my binomials going to be? M plus 1 times m plus 2. Now, I bring down what I have not used. What have I not used yet? Equals 0. Now, let me make this very clear. The first 4 problems we did not start with equal signs in them, so we cannot magically put equal signs into them. All right? On all the directions asked us to do was factor the polynomials. I just don't want you to magically insert an equals 0 and start solving equations when you aren't asked to. But in this problem, we are asked to solve the equation. So now that we've got it factored and it's set equal to 0, how do we finish this problem? We set each set of parentheses equal to 0. And we solve. How do we solve for the first m? Subtract 1, so m equals -1. And how do we solve for the second m? Subtract 2, so m equals -2. Awesome. Now, let's look at letter B. Is this one ready for us to just go straight into factoring? Why not? Everything is not on one side and it is not set equal to 0. So how can we quickly get everything on one side? Move the 24 and subtract it from both sides. Now, here's my next question. Can I combine -24 with anything on the left side? None of these are like terms, so we bring it down everything on the left side comes down individually. N squared minus 5n minus 24. Now, do you notice what form I put this in? Does that matter? Yes. If you want to make your lives easier, you will put it in standard form. And it's set equal to what? Now, normally we don't have to bring zeros down, but when it's the only thing left on the side of an equal sign, we have to. So there's nothing else on the right side of the equal sign, so we have to bring it down. Now, is this a trinomial on the left? What is the leading coefficient? Can we do our x method? Absolutely. So let's do it. What's going at the top? -5, the coefficient of n. What's going at the bottom? The constant, -24. Claire, my signs, the same or different? Look at your second sign. Second sign is negative. That automatically tells me that my signs are different. So one is plus and one is minus. I need factors of what, Emma? 24. So 1 times 24, 2 times, 3 times, anybody? 3 times 8, 4 times 6, and I know that 6 is going to start repeating. Now, am I going to be adding these factors or subtracting them? Say it with confidence. My signs are different, so I'm going to be subtracting. So which set of factors can I subtract and get a 5? 3 and 8. Now the signs matter. Which one is going to be positive and which one's going to be negative? 3 is positive and 8 is negative. My 5 is negative, so my larger factor needs to go with my negative sign. So when I write the binomials, I get n plus 3 times n minus 8 equals 0. And then how do I finish this problem? N plus 3 equals 0, n minus 8 equals 0. How do I solve for the first n? So n equals -3, and how do I solve for the second n? Add 8, so n equals 8, and that is lesson 7.5.